Ladies and gentlemen, please welcome Jens Henriksen, EVP and GM, Analog and Automotive Embedded Systems, Nxp。各位女士、各位先生，让我们欢迎 Nxp 执行副总裁 Jens Henriksen。
Good afternoon. My name is Jens Henriksen and I am with Nxp Semiconductors. Today, I'd like to talk to you about the autonomous future. So why are we here talking about the autonomous future? This is not some science fiction movie convention. This is COMPUTEX, right? But it is because the autonomous world, a world of machines that anticipate and automate, machines that sense, think, and collaborate and perform complex tasks all by themselves is not a line of a sci-fi novel anymore. It is on the cusp of becoming reality, and it will affect all of us. This autonomous future will make us more productive. It will make us more sustainable, safer, because of AI. AI is the single biggest innovation of humans to make this autonomous future a reality. AI becomes part of our world, of the real world, of the physical world. So actually the world where we interact with others, our surroundings, with things around us, that's what we call the edge. And to leverage the immense potential of AI, it has to be in the edge. So and today, I'd like to share with you how we will make this autonomous future a reality. So I will guide you through a couple of steps. So I will start why AI will move into the edge and how the AI in the edge will evolve. And I will also explore the engineering challenges, what it takes to bring it there, and what the industry can do to overcome those. Let me begin with a starting fact about data we generate. And that will help us to establish the stage for why the edge matters and why we cannot do it all in the cloud and why we need to empower the edge. So the world is projected to hit 180 zettabytes of data this year. So by the way, 1 zettabyte is a 1 followed by 21 zeros. It's a trillion gigabytes. So we have created more data in the last 3 years than in our entire human history, and it is not slowing down. So we generate data from everywhere, from factories, vehicles, homes, wearables, cities. But there's one problem. Most of the data goes unused. So let's step back for a moment, right? And let's connect to us as humans and how our brain basically works dealing with data. On average, a human takes in round about 74 gigabytes of data every single day. So sound, motion. And our brains have evolved to become extremely energy efficient, intelligent data processing centers. They understand context and prioritize the processing actually only what matters. Well, when I walked on stage, you watched me, I think so, right? And your brain tuned out everything around you and you didn't pay attention to the light or to the exit signs just until I mentioned them now. So this is context-based intelligent data processing. So going back to our data problem, right? So context-based intelligent data processing, that is what we need to handle all the data we generate. The word intelligent data processing typically brings to mind cloud, which is powerful GPUs and CPUs with this unbelievable compute processing power. But most of the data are generated in the edge, in the real world. So we generate about 500 billion gigabytes of data every day from the millions of edge devices all around us. And just as an example, a modern car generates up to 4 terabytes of data every day. And then again, it's not about reducing the data volume. It is about how we process the data and how to extract the true value from it. So sending this all to the cloud for real-time decision making is simply not feasible because of latency and cost, and we need round about 1,000 times more bandwidth than we have to send all the data to the cloud. Our physical world is just too vast to be uploaded to the cloud. So the solution is we need to bring AI to the edge and make AI useful for our day-to-day life. So Edge AI will break us free from encapsulated cloud-based use cases. We need intelligent data processing next to where the data is created, and that is the edge where the AI meets the physical world. So AI at the edge has actually quite a few benefits. So let's dive a bit into this one to get a good feeling on what we are talking about here. So let's come back to bandwidth. AI at the edge would reduce the data transport dramatically as the processing is done at the edge. And only very critical metadata will be uploaded or transported back and forth to the cloud. Also, the Edge AI does not need always-on cloud connectivity, which is really especially important in remote areas with very limited coverage. So another benefit is the real-time capability of the edge. So in real life, many processes must happen in real time. You can imagine many use cases where the real-time requirements are essential. Just think about the self-driving car in heavy traffic, or the real-time traffic light control at the same time in a smart city, or smartwatches detecting a health anomaly with immediate response required. Edge avoids the round trips to the cloud. Edge hardware is also optimized for energy efficiency. The 1,000-second floating point calculation done at the edge takes the same energy to send a single bit of data to the cloud. So very simple, less data sent to the cloud equals less energy use. Well, I like to highlight already at this point of the time that this topic is not that simple, because later I will also show you that the energy efficiency in the edge, especially of the processors in the edge, is also a real engineering challenge to overcome. So not that trivial. So coming to the next point, it's trust. And trust is many things. Basically, it's safety, it's security, and it is data privacy, personal data privacy. So we need to protect the data from being abused, falling into wrong hands. And the Edge AI reduces the cybersecurity risk by processing the data right where it is generated. So the data are distributed into many edge devices and not consolidated in one particular place in the cloud, which would it make very attractive to hack into. So in security terms, the edge concept, in the edge concept actually, the attack surface is clearly reduced. So Edge AI has real-life benefits, and it has tremendous potential to help us solve real-life, real-world challenges. And let's have a look into this one. Let's dive into one item, which is basically the energy management. So we have two examples, and I like to start first with the smart energy management. So if you look into this one, the global energy consumption is outpacing us. So from now to 25, electricity consumption is projected to double, possibly even triple. So beyond the traditional energy-consuming buildings and industries, EVs also require more energy. And, well, we are building smarter systems I'm just talking about, but they also consume more and more power. So what do we do when 75% of our electric vehicles or cars are all electrified? So what happens when the households, the factories, the cars, the cloud all draw from the same grid? We just can't throw more power at the problem. And the biggest problem actually is the peak load demand when all require energy at the same time. So AI can help contain this growing challenge. And we need energy systems that think and work with the grid. And I can help to smartly balance the load. You can think about balancing the load across city blocks, maybe beyond the city limits, maybe even on state level. Right? So the grids do not have to be built to the peak loads, but to the balanced loads. Let's move to the second real-life challenge. Each year, we face millions of unnecessary fatalities. 1.1 million people die on the road. More than 6 million people die from actually curable diseases, and we are facing approximately 2.3 million workplace deaths. Every one of this number is representing a human. And it is actually also representing a system that fails to intervene in time. These aren't rare, unpredictable events. They are typically a result of known patterns, so in traffic, in health, and in industrial environments. So the causes are often very well understood, but the system that should detect and prevent them often don't work. So it's not a lack of data. Again, it's a lack of intelligence of the point of need. Edge AI can help to reinvent the so-called Vision Zero. And we have the ability to see these risks. We see these risks coming, and then with Edge AI, we can help prevent the incidents in real time. So these are just two big areas where AI in the edge, in the real world, can make a big impact. So what have we seen in these examples? Actually, in a nutshell, AI is becoming part of our everyday life. And the edge is where it all comes together. This is where it's becoming real for us. This is the intersection of physical and digital, where the AI meets the real world. AI is moving to the edge. And actually, it is advancing faster than ever before. And this brings me to the second part of my speech, the rapid evolution of AI and the acceleration of AI moving into the edge. So let's go back a bit in time. In 1997, IBM's Deep Blue beat the chess world champion Garry Kasparov in, I think it was even a 6-game marathon, using symbolic AI and supercomputing power. No machine has ever done this before. That was the first occurrence and demonstration of the potential of AI. And I will never forget that. But let's leave this example a bit behind, and then let's have a look what happened since. So the artificial intelligence evolved significantly, and the innovation speed accelerated. So AI evolved from pure perception AI with object detection, computer vision, speech recognition capabilities over generative AI where context such as images, codes, text is created towards agentic AI that senses, thinks, acts, and learn practically like humans. So let's have a closer look on these evolutionary steps at the edge. So perception AI creates the aware edge. An aware edge is able to sense and interpret signals from the real world in real time. It detects objects or people, and it also recognizes who is who and what is what. So accurate detection and recognition was made possible by the immense progress in the neural networks, such as the CNNs and the RNNs. These neural networks were developed in the cloud, but the algorithms were optimized to run on the resource-constrained edge devices without losing the accuracy where it really is critical. So it took actually 10 years to bring the perception AI into the edge to create the aware edge. Then later, the edge became interactive. This interaction came with the breakthrough of the transformers. So transformers are the foundation behind today's generative AI models. So generative AI gave the ability to interact with humans in a very natural way through words and visuals, or even the combination of both. So you may recall that Gen AI appeared not that long time ago. In fact, the OpenAI large language models first became publicly available in 2021. So the explosion of progress in Gen AI models since then has benefited the cloud. But an even bigger beneficiary has been the edge. Because these Gen AI models, such like the large language models, the vision models, or the multimodal models, they all became smaller and smaller, more energy efficient, just suitable for the edge. So with Gen AI, we made the edge interactive. An edge that is not only able to sense, but also able to think. However, interaction alone is not enough, because, for a safe autonomy, this is what we want to create. You need AI that is able to sense, think, and refines its own thinking before it acts. That leap happened with Agentic AI. And with Agentic AI, the edge becomes autonomous. Agentic AI comes the closest to how humans function. So Agentic AI ties all the AI evolutions of the past together to create an edge that has gone from reactive to proactive. So Agentic AI at the edge senses, thinks, and acts independently, responding to the real world in real time. It evaluates the decision, refines them, and acts safely and securely. So Agentic AI enables the autonomous edge. The real value in edge AI comes with autonomy when the systems become human companions. And the AI evolutions typically start in the cloud. I mentioned this also earlier. And due to its enormous compute capability in the cloud, but then the capabilities are rapidly moving into the edge, aided by innovations in many areas, such as the silicon process technologies itself, and therefore resulting also in the processing capabilities, so of the compute processors, including their energy efficiency. The AI models became lightweight, and software frameworks for deployment were also developed. Everything making it fit into the edge. So let's come back to our chess example. So in the mid-90s, Deep Blue beat the chess champion, which is more than 25 years ago. Since then, we have seen significant acceleration. So less than 10 years for perception AI to come prevalent in the edge, and then around about 5 years for generative AI and agentic AI, we see less than 1 year later. So this acceleration is not by accident. It is because of the realization of the true value of edge AI in our day-to-day lives. So let's look at a practical case for Gen AI at the edge. So we have a short video, and this video is a recording of a multimodal Gen AI model running on a discrete NPU, which is built by our partner, Kinara. And also for this demo, we used Lava, which is an open source multimodal Gen AI model. And then we took this model, we ported it optimize it to run on this particular NPU on an edge device, right? And then we fed a video to it of an unfortunate accident on a factory floor and asked the AI model to describe what happened. So let's have a look what happened. So here you see the video. Poor guy, right? So he slipped, hopefully not serious. And then we asked the model to describe what did you see. And then you see what's coming out. It takes a little bit here. So, and you see, reading through this, you're realizing that that system, actually it is a camera, the edge device where it runs on, is interpreting the situation pretty well. Right? So in this case, you can clearly see that it is possible to have the AI in the edge. So this is an example of generative AI in the edge. And the most important takeaway of this video is that basically the system understands and interprets the situation very well. And so this is all done by humans these days sitting in one room. But this can be done by machines 24/7 later on. And then if you would also add a response, that would make out of this Gen AI pretty much more an agentic AI. And this all runs at the edge. But then the question is the agentic AI too complex for the edge devices? Is it better to be in the cloud with its enormous compute resources? And the answer is, it depends. Because the edge is more than just an edge device. So today and increasingly tomorrow, it will be not just the edge or the cloud. So we will see more and more implementation of local network edges, the so-called near edge. So this is actually a local network edge, and that could be a local edge AI hub or maybe a local inference server. A local cloud, so to speak, that has compute capability to run the more complex agentic AI systems rather than the smaller, more optimized AI agents run on the edge devices. So in reality, we will always see the cloud and the edge coexist, augmented by a local network edge. And then also the realization of AI in the edge or in the cloud is not a binary choice. Trade-offs apply, right? So use case by use case, it is an optimization decision of multiple and partly conflicting parameters. And if you look on the slide, there's on the one hand the bandwidth, the latency, the energy efficiency on the one side, and this tremendous compute power on the other side. But also the number of systems and the lifespan of the use cases really matters in this decision matrix. So in a nutshell, edge and cloud will always coexist. So what did we learn so far? We see 25 years of innovation. We see that AI in the edge is evolving from perception AI towards agentic AI. And we see the coexistence of AI in the edge and in the cloud. And all is accelerating to create the autonomy in our day-to-day lives. So let's dive a bit more into the topic of agentic AI. We see this as a new paradigm shift, a paradigm shift from AI as something we use to something that works alongside us. So when we talk about agentic AI, we are talking about more than just a model. We are talking about a software workflow construct built for autonomy, just like a brain. So as mentioned earlier, agentic AI starts with an AI agent, so single or multiple, and then each agent is powered by AI models, perception, generative, or both. And then each agent is really then built to a very specific task. And one may interpret a video, another one may assess sound, or another one might pave the path or a safe path for a robot to go. But the AI agent, the agentic AI agent, is not just a model to do a task. They learn and evolve from experience. And that is the real breakthrough of agentic AI workflow, adding structure so that AI agents become adaptive, autonomous learners. Let's dive into this a little bit and let's have a look on the picture here. So it really starts with an AI model being able to sense its surrounding, and this is outlined here with the word perception, right? And then this is resulting in a projected plan of what needs to be done. But then the agentic AI uses reinforcement learning to improve itself by exploring and collecting additional data. And finally, it connects the actions with outcome, the so-called feedback mapping, and it is rewarding itself for, let's say, very successful tasks to be fulfilled, or it is learning out of failures that were made. So this continuous learning piece makes agentic AI revolutionary. So these AI agents learn from real-life experience. They learn on the job that they are no longer limited to the data set they were originally trained on. So now we have an AI agent that can do meaningful tasks. And it goes further. Because when they collaborate, they can achieve an overarching goal. We will need multiple AI agents to come together and collaborate. And then, of course, the collaboration, as always, requires some kind of coordination, something to orchestrate this. And this is where the AI orchestrator agent comes in. So it is a specialized agent built to supervise, plan, and coordinate. So you can say it's like a project manager for intelligent systems, turning many agents into one unified force. So, when agentic AI gets implemented at the edge, AI becomes an autonomous human companion. It sees, plans, acts in the way we do to fulfill an overarching goal we gave it. So let's have a look at a real-life example. How edge agentic AI performs in action. Actually, in this case, on a factory floor. And on this factory floor, we gave a goal to an agentic AI system, monitor and respond to any abnormal situation to protect damage to humans and property. Well, now imagine a water line breaks. Moisture sensors and cameras, which are AI agents themselves, detect the leak and inform the orchestrator, the coordinator. So the orchestrator springs into action and triggers other agents to act. So maybe shutting off the water supply to the leaking pipe, closing access to the area, and so on. And the orchestrator agent in itself triggers maybe the cleanup and informs everyone relevant. So it does the steps because it plans and acts to fulfill the goal we gave it. But it also learns from what went right and what went wrong using feedback mapping and reinforcement learning, so the techniques I introduced early on. So here you have a system that thinks, adopts, and acts just like human would in a situation like this. So there's another benefit that agentic AI has, which is of great value. Therefore, let's look at the agentic AI more from an engineering perspective. Actually, an agentic AI workflow is a very scalable archetype. So the underlying software archetype can be scaled to an endless number of applications and use cases. They have minimum scalability and reuse potential. So just to trigger your imagination, here are a few real-world examples which can be fundamentally done all on the same underlying software archetype. So let's look into automotive. So can you imagine a self-healing in-vehicle network that detects faults, so maybe twisted or broken cables, and repairs it on the fly? Or think about agriculture. So maybe precision farming, where aerial ground agents inspect the crops, optimize the watering and fertilization, and detach maybe an on-the-ground robot to treat specific areas with minimal resource waste. Or smart buildings. Smart buildings interpret occupancy patterns in real time, adjusting climate control, EV charging, lighting, dynamically to comfort, energy efficiency, and savings. So this means we can build intelligent autonomous systems faster and deploy them across nearly all the use cases we can think of because of the scalability and the reuse. We will further accelerate with this the deployment of AI at the edge, an intelligent platform of scalability and reuse. But building the autonomous edge is not trivial. Let's continue to look at it from an engineering perspective. Let's explore what it takes to make this a reality and what challenges do we need to overcome. So the first challenge. The edge AI system needs complex integration. They cannot act in isolation. So what I mean with this is we need complete hardware and software solutions to cover the sense, the think, and the act. And most of the silicon solutions focus on compute only, but what we need are complete systems. Systems of processing, connectivity, and power management, security, and safety to tie it all together. And this also requires a very tailored software foundation to bring the hardware to life. So the edge systems are actually systems of a system requiring complex integration. It gets me to the second challenge. I mentioned this a few times before. The AI needs to be right-sized for the edge. What I mean is the models developed for the cloud are often too large, too power-hungry, too complex. For the edge applications, they must be right-sized. And on top of it, the new models, frameworks, and tool chains are emerging constantly. So the solutions in the edge needs to constantly keep up to this one and not stay in isolation just because they are in the edge. And finally, autonomy raises the stake for trust. And I told you, trust is safety, security, data privacy. So you need highest level of functional safety, and once you introduce autonomous decision-making into a system, you need to trust those actions will be executed safely and or at least fail safely if something goes wrong. You also need maximum security. You need to protect the autonomous systems from cybersecurity attack. Any data vulnerability or security breach is highly critical. So to make the autonomous edge a reality, we need solutions to overcome all of these fundamental engineering challenges. And that actually gets me to the final section. So what it takes to make the autonomous edge a reality from a semiconductor vendor's perspective. Let's have a look how such a system would look like. And you see it here on the picture. And let's go step by step. So let's start with the bottom. Let's start with the hardware foundation. The foundation of any autonomous system is silicon. And a system connected to the physical world needs a compute platform, connectivity, a data networking, and a power and energy network. And to build these edge systems, you need to have very scalable hardware building blocks like Lego blocks to tailor these systems to individual use case needs in each particular edge situation. So at Nxp, we provide all these hardware building blocks out of one hand. So basically, we have a very scalable processing platform from very simple microcontrollers to really high-end, powerful MPUs, largely focusing on the auto and industrial platforms. We have tightly integrated power management of these processors explicitly for maximum energy efficiency, and then secure and safe networking and connectivity capabilities addressing all the diverse needs you need for the different use cases, including various data rates. But then, the hardware is not just enough. You need comprehensive software to bring the systems to life. So what is needed is a complete software foundation, including libraries, tools, drivers, middleware tailored to the hardware and bridging to the application software. And accordingly, for the middleware, we provide a broad collection of solutions customers can pick from for their specific use cases. And some of the examples you can see outlined on the slide, like voice, graphics, vision, low power touch sensing, motor control, and so on. So with the very scalable and reusable hardware building blocks and the software foundation, we offer all the building blocks to develop these systems of a system. Let's discuss now how we can find a way to right-size then the AI to the edge. And therefore, deploying AI at the edge is not just a copy-paste from the cloud. So it must be right-sized to the constraints in the edge. So these are typically the compute power, the memory constraints, and they must be energy efficient. And I've mentioned this a few times. You cannot have water-cooled or dual-fan processors in the edge applications. So what we provide for this one is a toolkit which we call EIQ for model development and deployment. And you can see it outlined on the picture. It basically starts with a model definition and right-sizing. So you can bring your model, you can bring your data, and then we can right-size and optimize it for the particular edge. And it will be typically, which is shown there in orange, complemented by a local database for refinements, and then, of course, plenty of tools for the input and output data to the physical world. So with this toolkit, we have really the perfect toolkit to right-size and optimize for the edge, and as well also to keep the edge always up to date. That brings me to the last building block, the safety and the security. And you know, the trust is the foundation of autonomous systems, especially for autonomous systems at the edge, and therefore highest level of functional safety and security are required. And for functional safety, we leverage our automotive and industrial expertise, so industries where highest level of functional safety are needed. And we define the functional safety on system level, on hardware, on software, and even on the application end to end. And we have multiple elements to basically bring the functional safety of the systems to life. And similar to functional safety, also security needs to be defined on system level, and it requires multiple measures end to end. There's not that one thing that ensures security. It's always the combination of multiple measures individually for the system and the use cases. And so security is very deep in NXP's DNA, leveraging especially the know-how we have out of our passport, credit card, and mobile wallet business, and we deploy these highest levels of security also for the edge devices. And in security, you always need to stay ahead, right? So you always need to be one step ahead. And therefore, NXP is building already now post-quantum cryptography into the products actually already now. So to keep the security also up to date, we have also plenty of lifecycle management opportunities and secure over-the-air update. And also to live up to our strategic vision, we are also building to deliver to what's next. And we recently announced the intent to acquire 3 companies, Kinara, Aviva Links, and TT Tech Auto. And these companies will also further to help us to enhance our tool sets of bringing the AI to the edge. So Kinara provides industry-leading generative AI capable discrete MPUs that are really ideally suited for implementing Agentic AI in the edge. And then Aviva Links provides capabilities for high bandwidth asynchronous data transport. And then TT Tech Auto is a software company that provides safety-critical middleware platforms. So all these acquisitions, which are currently in the status of regulatory approval, will significantly enhance our autonomous edge capabilities. And if you have this all combined, you can see that we are very well positioned because we have all these building blocks and toolkits under one roof to address all the engineering challenges I have outlined early on. And this enables us to be a true solution provider, to develop and deploy the AI solutions to the edge with our partners and with our customers. As solution provider, we really want to reduce the burden of complexity our customers are facing. And then based on our deep application expertise, we focus on solutions. We focus the solution offering explicitly in the areas you see here, like the software-defined vehicles, the factory automation, energy management, AI vision. So these drives really truly, as a solution provider, innovation, fast time to market, and an optimization of the total cost of ownership for the industry. However, enabling the autonomous edge is bigger than just one company can do. It requires a collective effort. That is why we foster a broad ecosystem of partners, developers, and innovators, really a network of OEMs, system integrators, cloud providers, semiconductor vendors, you name it. Together, we make the autonomy real, scalable, and trusted, and not just in labs, but in the real world. Let's see how one of our partners brings autonomy to reality. Honeywell is one of our key partners in industrial and IoT, and they are implementing leading-edge AI technologies in their solutions for their customers, but also for their own factories. So let's listen what Suraj says, the CTO of Honeywell. Please.
Honeywell is a control systems company for the past 135 years. We have gone through three evolutions. One, we have leveraged deterministic AI for the last 100 plus years because we deliver mission critical, safety critical systems. The last 10 years, we have extended cloud to connect to our install base, and we have provided value added services. The last 2 to 3 years, with partnership like Nxp and other semiconductor providers, we are pushing AI at edge to really bring in intelligence at edge to really solve the most complex issues within the environment where our customers demand transformation. Industrial sector impacts everyone. There are three fundamentals that we try to really address. One, asset performance within buildings, industrial, and aircraft subsystems. Any downtime will impact the overall production throughput. That's something that we increase the lifetime of those assets. Second, people, labor shortages and skills gap. And that's where we come heavily to really drive the transformation of people and productivity. The last thing is anything that impacts the throughput and efficiency of their operations. And we actually help in optimizing and improving the effectiveness altogether. So for us, automation to autonomy are three fundamentals. One, which is assets. Second, people. Third one is operational throughput.
Thank you, Suresh, for the great insights. We are very happy about the partnership. And talking about partnership, especially here in Taiwan, we see the ecosystem come together in a very powerful way. We see shaping the ecosystem across the automotive, smart homes, smart buildings, and smart industries. So it's a story of deep collaboration, strong, trusted partners. And I see many familiar faces here together today in this very powerful network. In the powerful network of collaboration, so I see suppliers, co-inventors, customers, competitors. So thank you very much for your partnership. Let's recap now what we have talked about in the last 45 minutes. So we have learned that AI brings impactful intelligence to the edge. AI is accelerating at the edge faster than ever before. Autonomous edge is what's next, and Agentic AI shows the way. It's human-inspired to think, act, and learn. But autonomy scales only when we can trust it. So it must be built with safety and security. It takes an ecosystem to build it. And this is basically how we make the autonomous future a reality. An environment of anticipation, automation, where technology around us is intelligent companion in our day-to-day life. But innovation never stops. So what's next? Or maybe after next? So agentic AI is today, but AI will continue to progress and evolve. We don't know what will come in future. And many of you here right now may be working on the next evolution. So what happens, or better to say, when that happens, we, Nxp, and our partners will be there right here to bring it to reality. But that's for next COMPUTEX. Thank you very much. Thank you.
Thank you for joining us today. 感谢各位今日的莅临与参与。The next session, Gartner Special Event and Forum, will begin at 9 a.m. and at 9:30 a.m. tomorrow morning, respectively. Gartner 特别活动及论坛。